Let us now review and apply the concepts learned to sketch graph of polynomial function. The function given to us is f of x equals to 0.5 times x minus 4 times x minus 2 whole square times x plus 1 to the power of 5. Now this video is also important for those students who will be taking calculus. Now when you want to sketch a graph of polynomial functions, important characteristics which we should analyze are, first one is end behavior, right? And then I think zeros. Zeros are the real x-intercepts, which we're talking about at this point. And then y-intercept could be another important point to look into, right? I think with these three, we will be in a good position to sketch the graph of the given polynomial function. Now what is end behavior? End behavior is we're trying to understand what happens to the function as x approaches minus infinity or when x approaches plus infinity. Now how do we get that from the given equation? Two things. One is the degree and second is the leading coefficient, correct? They decide. Now in this case, what is the degree? We know degree is, let's add the exponents. 5 plus 2, 7 plus 1, 8, right? So degree is 8, that means even. And leading coefficient you get when you multiply all these x's. X to the power of 5, x square, x with 0.5. So leading coefficient is 0.5, which is positive. So let me write leading coefficient as equals to 0.5. In fact, what we're trying to see, it is positive. Now as you know, if the degree is even and leading coefficient is positive, then what should be the end behavior? End behavior is both sides up, right? So that means if x is approaching minus infinity, then y is approaching plus infinity. And when x is approaching plus infinity, y is also approaching plus infinity, right? So that is the end behavior, right? So if I have to sketch this polynomial, then basically it will be moving from quadrant 2 to quadrant 1, right? So it is kind of like this. It's going to move from quadrant 2 to quadrant 1. So that is how the graph is going to be. Now polynomials are continuous smooth functions, so the graph should not have any cusp, corner or breaks, right? Now the next aspect which we need to look into is zeros, right? So we have already understood the end behavior. Now let's try to analyze zeros. Now as you know, zeros have two aspects. One is the x-intercepts. So what are the x-intercepts? So x-intercepts are at the points where this function will be 0, right? So first one is at here 4, so we can say 4. This one will be at 2, and this one is at minus 1. So we have 3 x-intercepts for us, and zeros means we have to also look into their order, right? Order of zeros. Now what is the order of 4? It's a linear 0, so we say order is 1. This 0 has order of 2, right? So this is order of 2, and this one order of 5. That will give you the behavior of the curve at the x-intercept, right? Now let's figure out what is the value of y-intercept. So y-intercept basically is the value of function at x equals to 0, f of 0, right? So that we get as 0.5 times minus 4, substitute x as 0, times minus 2 square times 1 to the power of 5, correct? So that gives you, this will be positive, this is going to be positive, this is going to be negative, right? So we have 2 square is 4, half of 4 is 2, and times 4 is 8. So we get a value of minus 8, right? So minus 8 is our y-intercept. Now with this information, we should be in a position to sketch our graph, right? So what we know here is, So let me sketch it on this side. So let me draw a line here, and then we have zeros at 4, 2, minus 1. So more zeros are on this side. So let me draw the y-axis right there. Okay, so that is my y-axis. This is my x-axis, right? Now the zeros are at 4. So let's say this is 4 for us. Okay, and then we have one at 2. So that is 2. One at minus 1. So let's say this is minus 1. So these are the zeros. Order decides how will the graph move across the x-axis or around x-intercepts, right? Let's also mark the end behavior. The end behavior is both sides are up, right? So that is the end behavior. Now, so let's start from left to right. So minus 1 is our first x-intercept as we go from left to right, and the order is 5. That means it will kind of move like a cubic function, which will be kind of like this, but flat, right? Flat since the order is 5. You see that part. Now the next one is at 2 and the order is 2. That means it is going to turn, right? It is not going to cross the x-axis. The order is 2. So it will turn like the vertex of a parabola. And the third one at 4 is of order 1. It's a linear factor, x minus 4. So it will just cross. So that is the effect of the zeros. Do you see that? So the order of zeros dictates the behavior of the curve at the x-intercept. So that is the concept which is so important to learn. Now we have all the required information to sketch. So let's just join these points and sketch our graph. So we can say, well, this side it has to go up. So let's go up like this, and here is like a tilde, right? And it goes kind of like this. Join it, and then it has to go like this up. So we'll just go like this with a smooth graph, and let's join it like this. So that becomes the graph of our polynomial f of x, which is 0.5 times x minus 4 times x minus 2 whole square times x plus 1 to the power of 5, correct? So as you can see here, x plus 1, it is a 0 of order 5 at minus 1. Do you see that? So it has to be like a flat portion. And then we have the next 0 at 2, where the graph will turn like a parabola, vertex of a parabola. And then we have a linear 0 at 4 and just crosses x-axis. So the graph always crosses x-axis when the order of 0 is odd, but when it is even, it will not cross the x-axis. I think with that, we kind of get everything together for a polynomial function, and I hope with this you totally understand all the concepts required to sketch a polynomial function. I'm Anil Kumar, thanking you for going through my videos, and I hope and wish all the best for you. Thank you.